Welcome to Thuma Mina Teaching. This is your third lesson for Natural Sciences Grade 9, Term 2. In today's lesson, we will discuss the reaction between nonmetals and oxygen, as well as the formation of acid rain. Today, we will be building on our knowledge structures from Grade 8, where we learned about elements, compounds, and chemical reactions, as well as the knowledge we gained from our previous lesson when we learned about balancing of chemical reactions. The key word for this lesson is oxide. An oxide is a chemical compound that contains at least one oxygen atom and one other element. It is very important to understand the reaction between a nonmetal and oxygen as it affects our daily lives. When we understand these reactions, we can use our knowledge to produce compounds to our advantage or prevent reactions from taking place that have negative effects on daily life. Firstly, we will discuss the reaction between a nonmetal and oxygen. Just a quick recap. Nonmetals are found on the right-hand side of my periodic table, of which hydrogen on the left is also one. When a nonmetal reacts with oxygen, the product is always a nonmetal oxide. The general reaction is as follows. A nonmetal plus oxygen, the arrow indicating that a chemical reaction has occurred, and the final product being a nonmetal oxide. An important thing to notice for these reactions is that oxygen is a diatomic molecule, and therefore when it is written alone, it will always be written with a subscript 2. When a substance reacts with oxygen, the substance is oxidized, and this is known as an oxidation reaction. In our previous lesson, we learned about combustion reactions. Combustion is the process of burning. It is usually a rapid chemical reaction which produces a large amount of energy in the form of heat and light. Some nonmetals combust more easily in the presence of oxygen, much like phosphor. Pure phosphor is able to ignite spontaneously in the presence of oxygen. This means that it self-combusts, meaning to burn on its own. When we look at a matchbox, we usually see that two of the sides are covered in a brown reddish mixture. This mixture contains various substances, of which red phosphor is one. The matches are dipped in a mixture of potassium chlorate and sulfur. When we strike the match on the surface of the matchbox, the friction will cause the red phosphorus to react with the potassium chlorate, which will result in the match to ignite. Remember that this whole process occurs in the presence of oxygen. Let us take a closer look at the reaction between phosphorus and oxygen. The unbalanced chemical reaction will look like this. On my left-hand side, I will have the symbol for phosphorus, which is P, plus oxygen, O2. And on my right-hand side, I will have the product that is formed, phosphorus pentoxide, P2O5. The product is a non-metal oxide, and the pent indicates that there are 5 oxygens in the compound. Do you think that you are able to balance this chemical equation? Remember, in our previous lesson, I gave you the tip to start with the oxygen atoms on both sides. On my left-hand side, there are 2 oxygen atoms. And on my right-hand side, there are 5 oxygen atoms. We must find the lowest common multiple. The lowest common multiple of 5 and 2 is 10. So I know when I'm done with this equation, there will be 10 oxygens on my left-hand side and 10 oxygen atoms on my right-hand side. Remember, we cannot add a subscript. We can only add large numbers in front of the elements or the compounds. If I were to add a big 5 in front of the oxygen atom on my left-hand side, I will have 10 oxygen atoms on my left, because 5 times 2 is equal to 10. On my right-hand side, I cannot add any number between the phosphorus or the oxygen. It must be in front of the entire compound. I already have 5 oxygen atoms on my right hand side. If I were to place a 2 in front of the phosphorus pentoxide, I will now have 10 oxygen atoms on my right hand side. Now remember, that last change I made did not only change the number of oxygen atoms on my right hand side, but also the phosphorus atoms. Now instead of 2, I have 2 times 2, which is equal to 4 phosphorus atoms on my right hand side. Now it becomes easy. On the left, there is a simple single phosphorus atom in the beginning. If I were to add a 4 in front of the phosphorus atom, I will now have 4 phosphorus atoms on my left and 4 phosphorus atoms on my right hand side. This entire equation is now balanced. In our next example, we will study the reaction between nitrogen and oxygen. What is interesting now is that not only is the oxygen diatomic, but also the nitrogen. When we write the chemical formula for this equation, we will have to write N2 plus O2 will give me the product of NO. Wow, there's no subscripts with our product. Do you think this equation is balanced? No, because on our left-hand side, we have 2 nitrogens and 2 oxygens. But on our right-hand side, there is a single nitrogen and a single oxygen atom. It is very easy to balance this equation. We simply need to add a single 2 in front of our product. Can you guess what its name is? It is nitric oxide. We usually use it to make our cars go very fast. So let us quickly check, is this equation now balanced? On our left, there are 2 nitrogen atoms, and on our right, there are 2 nitrogen atoms. On our left, there are 2 oxygen atoms, and on the right, there are also 2 oxygen atoms. This equation is balanced. But what happens when nitric oxide further reacts with oxygen? If we allowed our product from our previous reaction to further react, therefore becoming a reactant with oxygen, this will be the chemical equation. Nitric oxide plus oxygen will deliver a new product. Can you guess what it is? Now it becomes tricky because it was just nitric oxide, but now it is nitrogen dioxide. The di indicates that there are now 2 oxygen atoms instead of the previous one where there were only 1. This equation is not balanced. And this is a tricky equation, so please follow with me. What makes this one special is that previously oxygen was the only oxygen-containing compound or element on my left-hand side. But now, both nitric oxide as well as oxygen contain oxygen atoms. Using our previous method of identifying the smallest common multiple will no longer work. On my left-hand side, there is a single nitrogen atom and 3 oxygen atoms. On my right-hand side, there is now a single nitrogen atom, but 2 oxygen atoms. It is unbalanced. And what are we going to do? So it's going to become a game of trial and error. We will start with 2. If I were to place a 2 in front of the product, therefore making 2 nitrogen atoms and 4 oxygen atoms on my right-hand side, because 2 times the subscript of 2 is equal to 4. All right. Now I have 2 nitrogens and 4 oxygens on my right-hand side. Over to my left-hand side, I see I have a single nitrogen atom, and I know I will need 2. So I will place a 2 in front of nitric oxide, making 2 nitrogen atoms, the 2 oxygen atoms from nitric oxide, as well as the 2 oxygen atoms from the oxygen atom. That means there are 4 oxygen atoms and 2 nitrogen atoms, which is equal to the number of atoms on my right-hand side. Now this equation is balanced. Our third chemical reaction involves carbon. Carbon is a nonmetal that is found in many different forms. Diamonds, which we use to make jewelry, is considered to be the hardest naturally occurring substance on Earth, and it is made up of carbon atoms. Graphite in our pencils, one of the softest known substances, is also solely made up of carbon atoms. This is why I think carbon is one of the coolest elements out there, because you never know what it might give you. Carbon compounds is considered to be the base of all known life forms on Earth. Carbon is more known to us in the form of charcoal, as we use it to make fires, to make food or heat up a room. Eskom uses charcoal to generate electricity in South Africa. So when carbon burns in the presence of oxygen, we observe an orange-yellow flame, and the product it produces, quickly breathe out, is carbon dioxide. The word equation for this reaction is carbon plus oxygen, the arrow indicating that a chemical reaction is taking place, carbon dioxide. The product that forms is a non-metal oxide, known as carbon dioxide. Carbon dioxide is a colorless, odorless, and tasteless gas that is not poisonous. The chemical equation for this reaction, we now use the symbols found on the periodic table. Instead of writing carbon, we use the symbol C plus O2, giving me CO2, carbon dioxide. We can clearly see that this reaction is balanced. On my left there is a single carbon atom, and on my right there is a single carbon atom. On my left there is the diatomic oxygen atoms, and on the right there is O2, meaning 2 oxygen atoms. The product of carbon dioxide is a compound made up of 2 non-metals. In our first lesson, we learned that when we name compounds, especially with non-metal compounds, we must indicate the number of atoms by using prefixes. In the case of carbon dioxide, there are 2 oxygen atoms bound to a single carbon atom. We indicate this by using the prefix di. So dioxide meaning 2 oxygens. In our chemical equation, we also notice that after each reactant and each product, there are letters written in brackets. These letters indicate the state of the element or the product formed. The S indicates that that element or product is in a solid form. The G will indicate a gas form. If it is liquid, like the case of water, we will indicate it by using an L. So in this formula, we notice that carbon is a solid, the oxygen and carbon dioxide were in gas form. The product that we formed in this reaction is carbon dioxide, and we use carbon dioxide in our fire extinguishers and to make fizzy drinks. When carbon dioxide is in its solid form, it is known as dry ice. In science, we test for the presence of carbon dioxide by making use of clear lime water. If carbon dioxide is present, it will turn the clear lime water into a milky substance. This experiment you should have done in grade 8. Our final chemical reaction for this lesson will be between sulfur and oxygen. When sulfur burns in the presence of oxygen, we are able to observe a bright blue flame. The product formed is a highly poisonous gas, and therefore we are not allowed to do this experiment. Sulfur dioxide is a colorless gas, but unlike carbon dioxide, it has a very sharp smell. The word equation for this reaction is sulfur plus oxygen, resulting in sulfur dioxide. The chemical equation for this reaction is sulfur, which is in its solid form, reacting with oxygen O2, with the arrow indicating a chemical reaction has taken place, and SO2 in its gas form. Much like the carbon dioxide equation, this equation is also immediately balanced. On my left-hand side, there is a single sulfur atom, and on my right-hand side, there is a single sulfur atom. There are 2 oxygen atoms on my left and 2 oxygen atoms on my right. This equation is balanced on both sides in terms of type and amount of atoms. Both carbon dioxide and sulfur dioxide are non-metal oxides, and when non-metal oxides dissolve into water, the water becomes acidic. And this results in what we commonly call acid rain. Acid rain holds harmful effects for plants and animals because when it rains, the soil becomes acidic, meaning the pH of the soil drops. This interrupts or disrupts optimal conditions for plant growth. The effects of this could be seen in the decreased amount of fruits, vegetables, or flowers that the plants will produce, or, in extreme cases, could result in the death of plants. Acid rain can cause paint to peel off buildings or make stone statues look older and weathered, thereby decreasing their value. This is a form of corrosion. Let's test your knowledge regarding the reaction between nonmetals and oxygen by answering the following questions. Our first question: what does the arrow in the chemical equation indicate? If your answer is to show that a chemical reaction has occurred, then you are correct. For our second question, you will need our periodic table of elements. Are you able to identify from this list which of the elements are nonmetals? In our list, we see that there is nitrogen, hydrogen, sodium, carbon, and magnesium. Nitrogen is located on the right-hand side of our periodic table, and this means that nitrogen is a nonmetal. Hydrogen is located on the left-hand side. However, remember that in grade 8, we told you that hydrogen is on the left-hand side due to its atomic structure. But hydrogen is a nonmetal. Sodium, located on the left-hand side as well, is a metal. And carbon, located on the right-hand side, is a nonmetal. Magnesium, as we learned in our previous lesson, is a metal. For our third question, can you list 3 physical characteristics of nonmetals? Nonmetals in solid form are dull and brittle in appearance. They are good insulators of heat and they are unable to conduct electricity. For our fourth question, we must state the name of the compound as well as the ratio in which the elements of the compound occur. For our first challenge, we see N2O3. N and O are both located on the right-hand side of my periodic table, meaning that both of them are nonmetals. And when naming compounds existing of solely nonmetals, I must write down the subscripts. The symbol N represents nitrogen, and the symbol O represents oxygen. The name for N2O3 would therefore be dinitrogen trioxide. And its ratio for nitrogen to oxygen is 2:3. Our second challenge for this question is SO2. S and O are both located on the right-hand side, meaning they are both nonmetals. S represents the element sulfur and O represents the element oxygen. It is sulfur dioxide, and the ratio for sulfur to oxygen is 1 to 2. Can you recall what the general product formed during a reaction between a nonmetal and an oxygen is called? And can you classify this type of reaction? The general product is called a nonmetal oxide, and the type of reaction is classified as an oxidation reaction, during which the nonmetal is oxidized. Can you still recall the types of energy that is produced during a combustion reaction? Light and heat. What color flame can we observe when phosphorus reacts with oxygen? The flame that we will be able to see is a bright white flame. Try to solve the following chemical equation on your own and try to balance the equation. Carbon that reacts with hydrogen produces methane. To write the chemical equation, I will give you a few hints. The symbol for carbon is C, and the symbol for hydrogen is H. The formula for methane is CH with subscript 4. Let's see how well you did. Remember, hydrogen is a diatomic molecule, and it always appears with a small subscript 2. Now note, this equation is not yet balanced. On the left-hand side, I see that there are 2 hydrogens. But on the right-hand side, where my product lies, I have 4 hydrogens. The lowest common multiple of 2 and 4 is 4. If I place a 2 in front of the reagent hydrogen, I will have 4 hydrogen atoms on my reactant side and 4 hydrogen atoms on my product side. Now my equation is balanced. When looking at this equation, what does the triangle below the arrow indicate in this reaction? The triangle indicates that there was heat added during the chemical reaction. When we look closely at the equation, there are small letters written in brackets. What does the S and G in brackets mean? The S in brackets means that carbon is found or used in its solid form. And the G in brackets mean that the oxygen and carbon dioxide are in their gaseous state. By looking at the equation, can you identify how many reactants we used in this reaction? I see that there are 2, carbon and oxygen. For our final question as it relates to this equation, when carbon burns in the presence of oxygen, what color flame would you observe? So it's good to remember that charcoal is made up of carbon atoms. So when you get stuck on this question, think of the color of the flame that you see when you are busy having a braai or a barbecue. The color of the flame is orange-red. The product formed is carbon dioxide. Can you think of 2 uses for carbon dioxide? As I've mentioned, Carbon dioxide is used for making fizzy drinks. We use it in our fire extinguishers as well as dry ice. We did this experiment in grade 8, but can you identify which substance we use to test for the presence of carbon dioxide? We use clear lime water. Now, if we were to insert carbon dioxide into clear lime water, what change would you be able to observe? In tests and exams, when we use the word observe, the examiner is asking us what change are we able to see? Now, if we added carbon dioxide to clear lime water, the clear lime water will turn milky in color. This marks the end of the third lesson. See you next time when we will be discussing acids and bases.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.